show it. Okay, cool. Okay, so I'll be try to be fast because I know there's not much time, and there's also Ben, who's actually my colleague too, who's here too. So I'm going to try to be quick and won't have time to go into a lot of details, so bear with me. But may I actually first ask how many of you are already working with Gen AI, let's say, right? You're working day to day. Wow, okay, awesome. And then how many of you are maybe just curious, right? You're learning and okay. And then what else? How many of you actually, one more question. How many of you are already working with vector database? Yeah, okay, oh, wow, so good. Actually, oh yes, of course, Eugen too. Yeah, we're competitors. Yeah. No, I'm just kidding, but we're good, we're frenemies. Yeah, so anyway, I'm just kind of curious because it's interesting too. Yesterday at the in Chicago, there are a lot more folks not having heard about vector database. So that's kind of interesting everywhere I go. But I would imagine here in Seattle and also Silicon Valley, probably more people have heard of it too. So, but I just wanted to get a sense of where everybody is. So, but bear with me too, because my talk is intended more for maybe people who are new, and you can be experienced too, but just new to this particular field. So okay, so that's why too I named this Enter the Brave New World of Gen AI. With vector search, we all know it came out in November, ChatGPT, and it just like changed the world. And so all of a sudden too, I have to say, I was actually not working with AI or ML, believe it or not. I'm actually, okay, let me kind of go further now. Who's Mary first? So, okay, so I'm a developer advocate at DataStax. And how many of you have heard of DataStax? I'm just kind of curious. Okay, good. How many of you are actually working with Cassandra? Just kind of curious. Okay, so quite a few. So obviously it's a really superior. We like to think, of course it is too. No SQL, right? Engine very strong, and Apple computer, for example, is our big customer, and it's really proven too. But anyway, so I joined DataStax a year and a half ago. I actually wasn't working on Cassandra. I work on Apache Pulsar on event streaming. So that was what I was advocating for a while. Prior to that, I was with IBM. I was a Java developer advocate. So, and so I have been working with Java mostly, and I was also a developer myself for over 20 years too, mostly in Java. So I'm also a Java champion and also the president of the Chicago Java Users Group too. So this is just a quick thing about me in here, but I'm really passionate and I really like doing advocacy work because I can reach out and meet people. So, oops, oh, wrong thing. How did that happen? Sorry, sorry. It's always happened like that. Okay, I think I just, okay. I think I should have used my clicker, but I didn't forget to bring it. So let me do that. Okay, so my talk here, right? Let me go back a little bit to a bit of the, just wanted to give, a sense of the agenda what I'm going to be talking about, right? So it's just some introductory materials first. And again, bear with me if you're already, familiar with this. And then I just want to also point out a bit of the theoretical meeting practical too, because I'm finding that there's just a lot of confusion as well. It's just Gen AI flying everywhere. And we just, but as such, just like anything else, you talk about one thing, everybody think is a certain thing. So let me kind of try to sort it out. Even I'm trying to sort that out. So I want to bring that up to, where the theory meets the practical stuff. And then also then go through, the terms, right? GPTs, NLP, LLMs, and then get into vector database, vector search, which is what DataStax is specializing in this particular field. And then also show you, I hope to have some time to show a quick demo of how, how you can start with working with a vector database that DataStax has. And then some benefits and challenges in sharing with your resources. So this I already have gone through. So I'll start with a brief background of AI first. So when I kind of switched to doing AI, I just figured that I should also get a good understanding of it. What is it, right? So artificial intelligence. But when I started doing some research, I realized that if you kind of think deeper, it started in 400 and 500 BC, according to some research. And that was when a Greek philosopher, Archytas, who actually invented the steam-powered flying pigeon. And so even though it's steam-powered, it's pretty much mechanical, but if you think about it, yeah, it's not like artificial intelligence, but it's a form of automation that he was trying to achieve that. That's so. And then if you kind of also look into the timeline, like on the 20th century, like basically kind of move forward to now or closer to us, the 20th century, there's actually a lot of activities started being done in the, like 1900s essentially. And there's also like, it is around World War II time frame, that's when, golden age of science fiction came out. It's like, can, machines take over all of these things? So we are like fascinated by this topic too for quite a long time. And then of course, Alan Turing, the father of modern computer, also kind of wrote about, can machines talk, right? Or can machines think? All of these. And so it's kind of interesting too, when you kind of look into now, there's ChatGPT and kind of more conversational type of thing is really about, text kind of processing and kind of generate responses that are really beyond, kind of imagination, so to speak. But I'd like to also point out too, even myself too, the very first like chat kind of conversational kind of robotic thing that I've tried was actually was using Emacs. Maybe some of you have used Emacs, the editor. And there's actually a doctor kind of feature in there, right? You can ask the doctor, like, I'm not well. And then it's very primitive. It would just respond back and said, what is happening with you? And it's kind of really primitive kind of conversational thing, but that would be kind of an early form of chat too. So, okay, so now, without going into all the details, but this is just showing you all of the timeline. But then of course, then it gets to like, I work for IBM. There was also the chess, the Deep Blue that IBM did too, that would beat Garry Kasparov at the time, champion of chess, and Deep Blue actually beat him too. So, but anyway, so those are kind of examples of all of these AI kind of attempts in the earlier days. So again, it's all about automation. Ultimately, is that we don't want to do too much work. We want the machine, somebody else to do the work. It's actually ultimately, that's what we were trying to do. And then let's then look into, AI, machine learning, deep learning to their relationship, because that also could be confusing. Sometimes we're using it interchangeably. But if you kind of look, this is kind of a very common diagram that describes, though in a kind of coarse way, right? You're talking about artificial intelligence being more of an umbrella term that describes this. Basically, we want to mimic the intelligence of human beings and the behavior of the patterns. And that would be kind of the overall thing. And then if you kind of drill down deeper, that's machine learning is basically the technique in which your computer can learn by looking at the data too, and then train itself. And it deals with their supervised training, unsupervised training, or reinforcement learning kind of way of making your machine learn. So then you basically like teach that machine to learn, so then you don't even have to teach that machine. That's the ultimate goal. And then of course too, it gets deeper is when we get into the neuroscience kind of level in which we're talking about machine learning, but it's kind of taking, kind of mimicking how does our nervous system works. So that gets into like deep learning, neuroscience in that. So that, and then in the current time with ChatGPT is basically, a mixture of machine learning and deep learning kind of techniques are involved. Okay, so now then I kind of move kind of more closer to now, which is our Gen AI era, so to speak. So what is Gen AI, right? It's a disruptive field in AI. Disruptive is because it has the potential to change the way how we create and also consume contents too. Basically too, the thing though is that you do need to ask, in order to receive your responses too. So it's basically the prompts, right? We have all heard about, you need to prompt it some input to tell what you're looking for. It's a way of, it giving it prompts so then it can go and search for what you're looking for. It generates the contents based on your prompts. So the prompts are very important. You need to kind of cater it. What you're looking for, you need to know how to ask in order to receive what you need to be looking for. Because if not, if you ask it not the right way, you'll be getting something that isn't what you're looking for. So, okay, so also too, one thing about generative AI is that the difference between that and predictive AI, which is predictive is probably is a longer history that we have been working with, right, before this generative AI came out. Predictive is a bit more, so to speak, right, more dealing with predictive things, such as like a business forecast or weather forecast. But if you kind of think about it, it's a bit more, dealing with, yes, looking at the data and then making prediction. And the thing is, though, what you're trying to look for, that information tends to be short-lived too. Like they're just some business you're forecasting maybe a year later what will happen. But once the time is gone, then it no longer applies. So it's like weather forecasts. So that's what kind of predictive AI tends to be focusing on more. Whereas with the generative AI, if you think about it, it focuses more on the art, the creative side of things. You can ask and it will create, your like an essay or write poems for you, or like, compose music and those kind of things. As it's more long lasting too. In some ways, it doesn't quite expire, tends to be. And so, yeah, so that's kind of more like the Gen AI. So I think that's what it has, the kind of wowing factors in there as well. So. Okay, so now let's kind of take a little bit look too into, since the new millennium too, if we kind of go kind of into the 2000s, basically we can look at a few kind of milestone too as, what, was being done to lead to where we are today. So in 2003, there was a team led by Joshua Bengio working on like this feed-forward neural network. This is also another neural network language model. Then in 2011, I'd say that's also a big milestone when Apple Computer came out with iPhone with Siri. So that's also kind of make use of NLP, natural language processing assistants too. So, and then in 2013, and a group of Google researchers led by Thomas Mikolov created the Word2Vec, which is techniques using also NLP that actually uses neural network to learn the word associations from a large set of text. So those are kind of, all these research are all like focusing more on the linguistic kind of side of things, right? The language processing. And then 2017, there was also another project led by also Google researchers. They had actually a simple network architecture called a transformer too. And that one is actually, if you kind of, some of you might have heard of it, it says they did a paper on attention is all you need. So it's basically the transformer is making use of the attention mechanism too. But I won't have time to get into all the details in here. I was doing some research. I thought that was kind of interesting too. Okay, so now, so that's a bit of a background, but now let's also take a look to it. Like I said, I was thinking there's a lot of theories that's involved with this field, but also too, it needs practical things, in order to make things happen, right? You need certain types of people to help it. So that kind of makes me think of the type of roles that would be involved in doing this, right? So basically, I look at it as there are data scientists. Data scientists deals more with, kind of here in this case is an example of a computer vision engineer. All of these data scientists, it's more concerns with the what, right? If we're working with Gen AI, it's basically what needs to be done, all of these things. But usually, too, data scientists are very theoretical. They kind of think of what needs to be done, but they are not the ones that are doing it. So they would rely on engineers, like data engineers, AI engineers, developers, ML ops, right? Operational folks, DevOps people to actually make things work for them. So that's kind of interesting to kind of see the different kind of roles that are associated with this. And then the data and AI engineers are basically the ones that dealing with the how to do something. So essentially too, I talked with a data scientist. He said that like he's kind of a speaker too. So he was saying that sometimes too, the data scientist actually doesn't know how to do things. And so they would turn to the engineers and say, how do you do it? And usually engineers would say, okay, use this, or say LLM, we need to use LangChain to do something. They would say, okay, go ahead and do it, because they just are not concerned with that level of implementation. So anyway, just I thought I'd bring this up too. So now I also kind of get into the GPT time generative pre-trained transformer. So essentially what it is that it takes, I talk about the prompts, right? That this is the GPT era that we're in. We do need to rely on some inputs, and they are like the prompts. It can be simple prompts. So the difference is that now these input are very natural to human beings too. It's no longer like how we used to program in traditional, kind of programming, in which you need to follow, certain words. They're very mechanical, kind of robotic, essentially. But these days we can actually ask the machine, in natural human languages. So those are kind of input. And then what it would do is that then this whole process would kind of take your input and then essentially do pattern matches that we call searches. But these searches are different too. They are called similarity searches and semantic search. For example, Randy was talking about that too. So that's also search, but it's not the traditional way. And because of that, it also requires new way of kind of storing the data and allowing you to query very fast storage of these. And that's where where DataStax comes into play. We can offer it to the marketplace is our vector database to help. So anyway, so again, GPT basically it produced contents like writing essays, a blog post, even computer program. We all know it too. They can actually write code for us as well. So it's really like earth-shattering too, in some sense, right? Because it's never thought could be done. Okay, so then let's take a look too at GPT. It basically first started showing up around like 2018 to just have a bit of a background understanding. So in 2018, so it's just in merely 5 years since it first came out. First, there was Alec Redford's paper on GPT, of a language model is published on OpenAI website. And that's when it first came out. And then 2019, very soon after that, then OpenAI releases the complete version of GPT-2. And that was trained on a data set of more than 9 mission documents too, including text from URLs that were shared in Reddit posts with at least 3 upvotes. So that was 2019. Okay, and then very soon, right? And during the COVID time, I think a lot of work's being done. And so 2022, startup company Stability AI, that also was a bit of a kind of breakthrough because it develops Stable Diffusion. It's a deep learning text-to-image model that generates images like based on text description too. So that leads to the DALL-E and also Midjourney too. Those are like diffusion-based image services. And then at the same year too, that's when like ChatGPT 3.5, the big kind of thing that came out when within like 5 days, it reached like 1 million users and everybody started talking about it. It's just pretty impressive too. So that's why I think led all of us here too. And we're all working on it now and taking the same journey. So now in the current year, 2023, this continues too. And also, just pointing out some more vendors, Microsoft integrates ChatGPT technology into Bing. Google has released its own AI chat bot, it's called Bard. And then also OpenAI releases actually GPT-4 too. Oops, that's kind of weird. Okay. And then also 2023, OpenAI releases a beta version of its browser extension for ChatGPT. And so all of these things, and it's just without saying, we know that as we're talking, there are new things that are coming out too. So it's just pretty amazing. So let's kind of take a little bit look then into, what makes this all happen. A bit on more of the, the academic side of things is basically, I call it this, it's more like the concepts, the theory is NLP, right? Natural language processing is an interdisciplinary subfield of linguistics and computer science too. So the primary concern is to process like natural language data sets, like they're huge, corpora of speech or text too. And then it uses like rule-based or probabilistic machine learning approaches, and then enables computer to learn from contents, right? And also including the contextual nuances of the language itself. So that's kind of like the difference is that you want to kind of be able to process this, let machine kind of figure out based on your input. It figures things out beyond, just what you can see. I think that's where it is. You want it to kind of draw some insights too from all your inputs. So that's something is kind of outstanding, I guess, in some ways than old ways of doing things. Okay, so then that leads to then large language models. So those are LLMs. We're all kind of talking about it. I think it's because it's kind of as, us working with ChatGPT, Gen AI, is basically is kind of the crux of it all, that what we work with as engineers, right? It's a type of machine learning model. It's also it's what is called like foundation type of model too. But the thing though is that it's not something that you and I, we do at home. It's just not possible because in order to, we know, you need to actually, it costs a lot of money. It needs a lot of GPU very compute intensive, right? Dealing with all of these data. And also not only that too, even with many GPUs, it's going to take days, if not like, well, actually I'd say weeks and months, right? If not kind of, like a year or something, well, no. But okay, so essentially too, we know that it's very expensive, these LLMs. So it's like not for all of us to do. However, just wanting to point out too is that with the way it is working, yes, you can generate all these model with this particular set of data, maybe up to a certain date. And then what happens now between where it cuts off to now, there is still data that you need to kind of process. So that's the kind of challenge that we have to kind of figure out. How do you actually, how can you essentially do real-time data, introduce that into your model? So, but anyway, but this is the LLMs. And what it does is it performs like NLP task essentially, and it generates and classifies the text and also answers questions, right? Answers questions based on the prompts, just like a human too, and analyze all the sentiments as well. Okay, so this too is just some examples of API frameworks that are probably more popular these days. LangChain, I think a lot of you probably are already working with it. Then there's also Meta or Facebook that came out with Llama, and now it's Llama 2. And then also Google has Palm, and also that Palm that works also with its Vertex AI stuff too. And then of course, Hugging Face, also another like a hub that you can use to kind of for your Gen AI application. Okay, so here, and because I work with Java, and I also strongly believe that I actually did a blog article too. Basically, Java is not traditionally AI centric, so to speak. It's always Python. However, Java itself too is proven is to be very, robust and very enterprise capable. As we know, the company, I mean, like all the enterprises of the world are still heavily using Java. So I like to think that Java should eventually would have more support for that too. So at this point in time too, especially if you're involved with Java, so just wanted to point out too, there are some libraries that are worth looking into. JLlama is actually developed by one of our engineers. Okay, I'll be quick. I was told. Okay, yeah. So JLlama, and then it's essentially based on the Llama, and then it's Java. And then also one I want to point out, second one is JVector. This one is developed by our founder of DataStax, and basically it makes use of, if you're familiar with Java, the project Panama with working with the SIMD API too. So it makes kind of accessing like vector database or vector data very efficiently too. So if you're kind of looking into that level of details, and you should take a look into JVector. And also that's why we believe that Astra vector database will be very robust. We already have very robust Cassandra NoSQL database. And then with this vector technology, we're going to be leveraging on JVector. That's also making use of like, there's a disk ANN kind of technology too, and the SIMD from Project Panama. So it should be a very robust underlying kind of vector search kind of capability in there. Okay, and then there's also LangChain 4J, and then 4J, that's what is essentially Java, and then Llama 2 too. Llama 2 is actually direct port from Llama C. So, okay, so real quickly, I know I don't have as much time. So again, vector database and vector search. So what is vector database? So it's essentially a purpose-built database, right, that serves up like vector data type for complex machine learning purposes too. I mean, as such too, if you kind of think of now we need to have machines that handle processing, in a human ways. As we know, as humans, we're dealing with many, the data that has many dimensions and patterns and relationships that are very complex, in which like traditional database cannot handle. So that's when like vector data type comes out. I mean, as such, vector data essentially is multidimensional. As we all know, we normally work with traditional ways, scalar kind of data, which is single dimension, but now we need to handle data that's multidimensional. So, and also has a good way of storing it, and also allow you to query it really fast too. So that's what like vector database is. I know I'm kind of going too quickly, but just to give you some idea. And then there's also this particular technique is called approximate nearest neighbor, ANN, is there to help you with doing all of the proximity searches, because you're basically taking a string, for example, a simple example, you get your input and you tokenize it, and then you break it down, you assign numerical representations called embeddings to it too. And then from there, right, then is basically use a technique called ANN to determine, how far is it from where your query string is in order to return to you the response based on how far do you want to search, right? How near do you want to search it? So, okay, so basically, let me kind of quickly then, what are vector embeddings used for? So all of these here, they're for vector search, right? And clustering, recommendations, anomaly detection, diversity measurement, and classification, all of these things too. So they kind of have a lot of usages in there, and it's absolutely needed for Gen AI type of applications. Okay, oops, and I think I have one more. Okay, so just real quick problem with traditional database in AI is basically it can't handle all of the complex data that's required in AI, right? And I already kind of talked about it. So we need also to provide the context for Gen AI type of processing too. So, so that's why too, essentially we want that. And this is just a diagram to kind of quickly explain too. There's also the RAG, what you call a retrieval augmented generation pattern, in which you can then use that pattern to kind of fill up. Remember, the LLM, the foundation model, cannot contain all of your data set, and you do need to kind of feed in the data that's newer to it. So you can use this RAG pattern to help you to do it. But this is, again, just an example too of how kind of conceptually it works in here with our vector database. So. Okay, so I guess I won't have time to do the demo, but really quickly kind of show you, maybe I just really quickly see if I can show it to you real quick. Okay, so I actually have, okay, so this is our data stacks. You are welcome to sign up, but I'll give you the link in my my slide deck too. But anyway, let's say you can all get like $25 credit per month, and then it gets refreshed every month too. So you get $300 a year to try this out. But I just want to really quickly bring this up to you. So you don't need to give your credit card. You just kind of sign up with your email. Then you can get in and use it and just follow it. There's a lot of example in here and some like kind of example for you to try out. You can create database really quickly, vector database, for example, and it will quickly spin up one for you to use. Again, doesn't cost anything extra. I know Eugen is right there, so I'll be quick. But okay, so all right, so now here's all contains all of the links to it, but basically benefits, no need to talk about, we all know what it is, but beware of issues like hallucinations and some ethical concerns, that we are all aware of, as good as it is, we need to be made aware of it, and also the real-time aspect of it. And here are all the resources. If you like my slide deck, this is the QR code and also the bit.ly link. If you miss it, don't worry about it. I'll give you my contact information and we can have more conversation. So, okay, so this one is the one with to sign up for our Astra database, the vector database. So yeah, I encourage you to do it. Again, we don't spam you. We don't ask you for your credit card. So I like that too. So yeah, I sign up for one myself as an outside user. I hardly get much email, so I can guarantee that. So okay, all right. And then here are just the rest of the the thing. I also have a weekly podcast with my colleague Aaron too. It's if you follow us on DataStax developers on LinkedIn, then you'll get notification as well. Okay. And then also my own Twitch stream, but if you get this slide deck, you will get that. And then the rest, I guess, no need to talk about. And here, we actually will have Ben talk about the Cascada products, which is our real-time AI. And then we also have an open source library called Langstream that's coming up that's basically enabling event streaming with the RAG pattern too. And with that, thank you so much and really appreciate you. This is how you can stay in touch with me. Thank you. Yeah. 2 questions, okay.